1874 monsoon was one of nature's fiascos. Hundreds in Bangladesh and Burma and their crops were washed away by the floods. But most of neighboring India stayed short of rain, sustaining fears that poor monsoons are becoming more frequent. Historians of the climate suspect that calamities of this sort result from the cooling of the world. Dr. Smagorinsky, speaking for meteorologists who work with the giant computers, warned against simple-minded forecasts. Yet 30 years ago, the northern hemisphere was exceptionally warm, so you might think further cooling more likely than rewarming. Man-made carbon dioxide could be actually helping us by delaying the cooling. But the history of the rain in Rajasthan brings us to a climatic change of a different order over longer periods. Rajasthan was even drier than it is today, 18,000 years ago. That was during the Ice Age. And at that time, too, the Gulf Stream ran quite differently. In the Little Ice Age, it swung a little way south. But in the Big Ice Age, as we'll be seeing, it turned right down to Africa. It slammed the door and left Europe out in the cold. So an ice age isn't ice piled on the northern lands. The climate changes worldwide. These speckles represent pollen of oak trees that grew in tropical South America. Going backwards in time, layer by layer through the bed of a lake in Colombia, the amount of oak pollen suddenly drops. We're back to a time when the climate was so dry that few trees grew. This, too, is 18,000 years ago, in the depths of the last ice age. Dutch scientists have been doing this work, and we'll meet them later on. The amount of heavy oxygen in the Greenland ice, remember, records climates of past centuries. And the varying heavy oxygen in the shells of sea animals buried in the ocean mud reveals the long and rapid succession of ice ages. By past form, an icy world is normal, and our own relatively warm period is due to expire any time now. To help assess the risks, let's see how the weather machine works when it's running as a refrigerator. Nowadays, the winds that sweep out to sea from Africa are laden with dust from the Sahara Desert. And during the last ice age, too, sand blew from the Sahara into the Atlantic. It tells James Hayes that the trade winds were stronger then. The sand outweighed the sea animals. In the recent topmost layers of the ocean bed, they're roughly equal. Samples of mud are snatched from the ocean bed by research ships. VEMA has been doing it for 20 years. A tube that automatically hammered itself into the mud lying 3 miles down comes back aboard. At first, the samples were wanted for research into the building of the ocean bed itself, but the mud has proved invaluable for investigating climates of the remote past. Samples collected from every ocean by VEMA and other ships are carefully stored at the Lamont Doherty Geological Observatory near New York City. For Professor Hayes and his colleagues, it's an archive of Ice Age history. This one's from the North Pacific, meaningless mud to the casual eye. But there's ash from a great volcano that dusted the ocean 400,000 years ago. It helps to fix the ages of the layer of mud. Neil Opdyke has another dateline. The mud adopted weak magnetism as it settled on the ocean bed. This instrument detects it. The direction of the Earth's magnetic field recorded in the mud swung right around 700,000 years ago. That event dates the layer where the direction changes to the older magnetic alignment. Reliable age markers help in locating mud for any chosen period.
The critical 18,000 year level should be about in this area here, with warmer fossils preserved above it and cold water glacial fossils preserved below.
Small fossils tell of conditions in the ocean when and where they lived. These animals and plants needed fairly warm water, while these lived in a polar sea. Using the mud recovered from all the world's oceans, 4 American universities have launched CliMap, an ambitious project for mapping former climates. At Brown University in Rhode Island, Nilva Kipp takes the temperature of the water, 18,000 years ago. Just as camels or polar bears are emblems of climate on land, so are these little sea animals recovered from the ocean mud. Dr. Kipp has sorted them according to their species. Their comparative numbers give, in fact, quite precise indications of temperature. Careful counts of the populations of different species can be translated by computer into a figure for the temperature of the sea surface where they live. The changing winter temperature in the tropical Atlantic disclosed in successive layers of the ocean mud. A particularly cold phase stands out. That was 18,000 years ago during the last ice age. They're charting temperatures across all the oceans for that time. The combined efforts of a score of scientists working with thousands of samples from the ocean floor add up to a snapshot of worldwide temperatures 18,000 years ago.
I know you don't agree with me, but the polar front only moves about...
There were big differences. Nowadays, across the North Atlantic, warm water from the Gulf Stream spreads strongly towards Europe. But when North America and Europe were plastered with ice, the polar water extended far southwards. The Gulf Stream went to Africa. The Ice Age and the present. The aim of CliMap is to see the weather machine working as a whole. So this phase of the work also demands a new portrait of the northern ice sheets, 18,000 years before the present. It's hard to recognize North America and Europe half hidden under the ice. Now the mathematical modelers have plenty to work with. Lawrence Gates at the Rand Corporation in California communicates with a powerful computer on behalf of the CliMap program.
All of these data come together here. We have information on the distribution and thickness of the ice 18,000 years ago and the amount of sea level lowering, which was approximately 85 meters. This exposed new land around the edges of the continents, which we must take into account in the calculation of climate. We have here data on the sea surface temperature 18,000 years ago, and in addition we have information on the reflective power of the Earth's surface, which determines the amount of energy available to drive the climate. All of this information comes together in the form of a mathematical model which we run on a high-speed computer, and we simulate the climate as of a typical August day some 18,000 years ago. From this, we obtain the distribution of temperature, pressure, the wind pattern, and the rainfall.
In 1974, the CliMap computer drew its picture of weather during that most recent ice age. The areas of high and low pressure for that typical summer's day imply strong winds across North America from the east. Nowadays, they're southerly in summer. And in Europe, too, strong easterlies. These particular wind patterns meant a very cold and dry climate in both Europe and North America.
The next job is to check on these results by comparing with information which was not actually put into the calculation, such as the distribution of vegetation around the world 18,000 years ago.
One place where they're checking is in the Netherlands. The Dinkel Valley lies near the German border. It's a monument to the effects of the most recent ice age. Erosion has laid bare an arena of old and peculiar ground. It matches that CliMap's date of 18,000 years ago. The Ice Age wind blew the soil away and left behind the heavier pebbles. Alex Wimstra and Thomas van der Hammen from the University of Amsterdam are pollen hunters by profession. But in this particular layer, there's no pollen at all. The land was dead, even though the ice sheet did not reach this valley. So what was this corner of Europe really like during the last ice age? Dr. van der Hammen tells us.
The Netherlands was a cold and dry polar desert 18,000 years ago. In the riverbank, we find here the same layer of pebbles, wind polished, called a desert pavement. And running down from this level are frost cracks caused by the extreme cold.
Cold and dry. In the CliMap project, the computer deduces winds from the east. They'd be dry, all right. Loamy soil below marks a milder interval 30,000 years ago. Then a few shrubs braved the cold here in Holland. Higher up, A layer of peat, 11,000 years old, proclaims the passing of the Ice Age. The forests killed by the cold renewed themselves. The peat contains pollen, telling of birch trees that grew here. Then came pine trees, then oaks. Later, men felled the oak forests of Europe, but nature's more thorough at destroying environments than we are. In the Ice Ages, much of Europe looked like Antarctica today, smothered by immense ice sheets. After the air and the oceans, the ice is the third great fluid of the weather machine. One theory pictures the Antarctic ice breaking out, surging into the sea, flooding and chilling the world and triggering an ice age. At present, as it flows into the sea, it forms a floating shelf of ice as big as France. Fortunately, it's advancing only at a snail's pace. Yet the threat of an ice age remains. Someday our northern lands are likely to disappear under new ice. We're in Greenland again, approaching the most substantial ice sheet that survives at this end of the world.
2,000 meters, 6,000 feet.
An American aircraft is fitted with special Danish antennas that launch radio pulses into the ice. A receiver records on film the faint echoes from the bedrock far below. Preben Gudmundsson and his radar specialists from Denmark's Technical University explore a long-lost Greenland. Hills and valleys where trees once grew and animals bustled lie buried more than a mile deep. It's hard to imagine and not easy to survey. One of their tasks is to help in choosing places for sampling the ice. We visited the drilling team here at Kret early in the program. For a good ice record of the changing climate, you want simple underlying terrain, where the ice flows in predictable ways.
37. How many miles does it show?
The bedrock isn't the only feature their radar reveals. Professor Gudmundsson and his colleagues detect strange layers within the ice itself. The aircraft has traced for hundreds of miles between the hilly bedrock and the surface layers that may tell of widespread melting during relatively warm periods. Whatever the reason, they imply repeated changes of climate. The climate's always changing, and in its sluggish fashion, the ice confirms the trend. An ice age is like perpetual winter, when the summer sun neglects to bring the northern lands back to life. The big computers begin to grasp the processes of wind and water, but the comings and goings of the ice may elude them if the reasons lie outside the normal workings of the weather machine. One search for possible causes of climatic change is in progress in Copenhagen, where the samples of ancient ice from Greenland divulge their contents. They're carefully protected from contamination inside a tent. How strong is the connection between periods of cooling and big volcanic eruptions? That's what Klaus Hammer would like to know. His instrument finds in the meltwater the wind-blown particles that dusted the snow when the world was cold. Drastic changes of climate demand powerful explanations. A very harsh event occurred 90,000 years ago, when the climate was not very different from our own. Suddenly, the world was plunged into the full cold of an ice age, perhaps in less than 100 years. It lasted just a few centuries. For Willie Dunsgaard, it's cause for concern.
This piece of ice records a spectacular cooling. In fact, it's a quite new discovery for us that the Earth can turn so cold so fast. What was the reason? We don't think the volcanic eruptions did it. Maybe it was due to enormous breakouts of Antarctic ice. The problem is, could that happen again to us right now? Or could we accidentally provoke such a catastrophe? We must find the reason for this natural event long ago.
That brief, possibly sudden cooling of 90,000 years ago had worldwide effects on life. But In a major ice age, large territories simply vanish, although other land emerges from the sea because so much water is locked up as ice. Luckily, the ice comes no further than this. Just a little colder, and the ice could reach the equator. Then we'd have a dead planet, a ball of ice. Freeze or fry. Suppose we tried to keep the Earth warm by putting, let's say, a lot more carbon dioxide into the air. That could melt the present ice sheets. The sea level would go up 200 feet, and we'd all have to take to the hills. Professor Bolin in Sweden mentioned that the heating might reinforce itself. Our sister planet, Venus, has suffered runaway heating, smothered in carbon dioxide, far too hot for life. But for the Earth, renewed freezing seems the nearer danger. Icy phases have occurred several times in the Earth's long history, when the continents moved into critical positions. The stage was set for our own series of ice ages by Australia breaking away from Antarctica 40 million years ago, isolating it in the chilly Southern Ocean. As the whole world slowly cooled, our ape-like ancestors in Africa found tropical forests giving way to grassland where a man could sprint. 2 million years ago, severe icing began in the north. It helped shape human evolution because drastic changes of climate favored resourceful animals like us. Modern men and women like ourselves first appeared during the most recent ice age. The ice comes and goes. The main reason is that the Earth changes its attitude. Its axis is tilted in relation to the sun. Each winter, we're tipped away from the sun, and in summer, toward it. But slowly, over thousands of years, the Earth also rolls a little. Its axis wobbles around and around. And its orbit sometimes takes it nearer and sometimes farther from the sun. These antics alter the sunshine falling on the northern lands in summer, sunshine needed to melt the winter's snow. A rough calculation of the freezing and melting that results looks like this: a pattern of warm and cold periods. Comparing it with the ocean bed mud and its record, the white bands show the coldest periods here, and here, and here, and so on back. By this reckoning, in fact, the Earth began its decline into the next ice age 5,000 years ago. The big freeze might be as deadly as nuclear war. So, just how serious is the threat of ice to us or to our grandchildren? According to the old picture of ice ages, there's no risk at all. Snow piles up in the mountains, glaciers advance down the valleys, merge and creep over the plains, icing at a snail's pace. It would take 20,000 years or so to make a big ice sheet. At worst, you'd spot the ice looming up and advise your grandchildren to settle a few miles further south. But now, a new and quite different theory has to be taken seriously. It says the snow can seize large areas all at once. It simply fails to melt in the summer. Then, year after year, the ice sheet grows from the bottom up. Human beings suffering this snow blitz would find their homelands abruptly vanishing under the snow. They'd have to trek a long way to find fields free from snow. I'm afraid this theory gains strength from another very recent discovery. Britain is often visited by ice sheets. It was thought that the ice never came further than London, but now it turns out that in the worst ice ages, the English Channel was a huge glacier. There's the coast of France. What's more, the ice didn't come from the English hills to the north, it came from the west. The snow from which this English Channel glacier flowed could pile up only after a lot of ice had formed in other parts of the world and lowered the sea level. That laid bare the seabed south of Ireland, and there snow from the Atlantic fell heavily. Then the mound of ice sagged eastward up the channel. So this ice started not on high ground, but on the lowest, the dry seabed where the snow fell and failed to melt. In other words, a snow blitz. And by that snow blitz theory, a thin crust of ice can form very quickly over large areas of land. If the theory's right, the risk of widespread icing in our lifetimes is no longer quite zero. And now the ocean mud bears it out. From a piece of the ocean bed 100,000 years old comes a haul of little shells. A handful of them will be enough for weighing all the world's ice sheets. Nicholas Shackleton of Cambridge University is looking for particular animals. While most of them spent their lives near the sea surface and sank only when they died, he's picked out these creatures that dwelt in the utter darkness at the bottom of the ocean. Undisturbed by the weather at the surface, they've monitored the atomic makeup of the ocean water. The ice sheets that form on land steal water from the oceans. But as a result, the oceans themselves become richer in the heavy kind of oxygen, and so do their inhabitants. The chalky little shells dissolve in acid. When their oxygen's been weighed, the fossils from successive layers of mud announce how much ice there was in the world when they were alive. Dr. Shackleton's latest findings confound some long-standing ideas about the rate at which ice sheets grow.
These microfossils are telling me that at the end of the last warm period, like the one we're living in, about 120,000 years ago, ice began accumulating very quickly indeed. Averaged over northern lands, it must have been accumulating at something like 18 inches a year. We are forced to imagine, instead of the old idea of an ice sheet accumulating very slowly, something very rapid happening. Over northern areas like Britain here, snow must have been falling and simply not melting away the next summer, so that snow continued to fall from year to year. Areas like northern Europe, northern Russia, Canada, and the United States were becoming ever increasingly blanketed in snow.
Sooner or later, the nations will have to sink their differences and try either to avert climatic disaster or else to survive in spite of it. This is David Prowett, WNET in London. Good night. The preceding program has been made possible by a grant from Champion International Corporation.